Mahatma Gandhi once said, "The earth, the air, the land and the water are not an inheritance from our forefathers, but on loan from our children. So we have to hand over to them at least as it was handed over to us. And what we hand over to the next generations is a world with huge issues. Issues with our land, water and air." In this episode, we turn our lens to look at issues that affect our environment. We focus on 4 issues: air pollution, ozone depletion, solid waste management, and catastrophic episodes like oil spills. In each case, we will look at the issue and explore solutions that science and technology offers. We start off with winter in North India. Every winter, much of the Gangetic Plains struggle while coping with extreme air pollution. The World Health Organization released an updated list of most polluted cities globally. If we look at data in 2016, 14 of the 15 most polluted cities in the world lie in North India. These include Kanpur, Faridabad, Varanasi, Gaya, Patna, Delhi, Lucknow, Agra, Muzaffarpur, Srinagar, Gurugram, Jaipur, Patiala and Jodhpur. Now what happens in this season is that the pollution and dust particles in the air are not able to escape from the atmosphere due to stagnant winds. This kind of visible air pollution is composed of nitrogen oxides, sulfur oxides, ozone, smoke or particulates, along with less visible pollutants like carbon monoxide, CFCs and radioactive sources.
Normally, in summer, air rises very high to disperse. Now, during winter, because of the lower temperature, the mixing height of the air, it comes down. So, the air cannot rise very high. This means there is no wind in the city to blow the pollution away. And because of that inversion layer settling in, the cold temperature, moisture, all of that together, it traps the air very close to the ground level.
But the accurate way to calibrate pollution is based on 2 kinds of particles. PM 2.5. These are microscopic particles, 2.5 microns in width and almost 30 times smaller than the diameter of a human hair. And PM 10, particles that are 10 microns in diameter. The smaller PM 2.5 particles can linger in the air longer and penetrate deeper into the lungs than larger particles, which is why they're the bigger concern for health officials and a high priority target for reduction. Now, if we stop and look at what caused this pollution, there is a range of factors. Crop burning in states like Punjab, Haryana and Uttar Pradesh is a key reason why this region is experiencing such high pollution levels in the recent past. The geography of the Gangetic Plains adds to the issue. Trapped between the Himalayas in the north and the Vindhyas in the south, pollutants are unable to disperse very far, adding to the intensity of the pollution. These cities lie in some of the most densely populated areas in the world. And so, the demand for energy sources and the consequent burning of fuels is extremely high. Cooking methods in poorer households, chulhas, contributes to 25% outdoor pollution in India. Industries are responsible for a big chunk of toxic gases in the air, especially the ones using coal for power. Another year-long pollutant is vehicular emission, especially in our cities. The dust from construction activities and the burning of trash, which can contain plastic, rubber and metal items, also gives off toxic emissions. Weather factors like the wind direction also plays a big role. Many of the pollutants found over Delhi are not all generated in Delhi, but transported from other places. All these factors come together to create a huge environmental disaster. Living in Delhi during these months is equivalent to smoking 50 cigarettes a day. Research shows that there were 9 million premature deaths worldwide stemming from air pollution in 2015. More than 2.5 million of these were in India, the most in any single country. Air pollution was also responsible for 3 times as many deaths as AIDS, tuberculosis and malaria combined. In order to help citizens cope with this level of pollution in the air, scientists at IIT Delhi have come up with an interesting innovation. Using nanotechnology, they have invented a nasofilter that costs only 10 rupees and can prevent particulate matter PM 2.5 from entering the body.
We are using a very thin layer of very fine fibers, which are also known as nanofibers, in the range of say 250 to 300 nanometers. And by using this technology, we are able to get an efficiency which is very high. That means when we use these filters close to our nose, even in a very small size, we feel comfortable, as well as all kind of pollutants, virus, bacteria, etc. are filtered through this.
This filter is lightweight and small. It looks and feels like a small strip of paper. And so, it is super convenient. When worn, it can prevent respiratory diseases since it can eliminate 95% of PM 2.5 pollutants.
The kind of available solution that are being present in global market are basically full face mask or insertion filters. Here we are again different. It's just a patch that you need to stick to your nasal orifice, and it's more comfortable and more aesthetically good. It is the most affordable solution present in the global market right now.
Now, this is a way to cope with the situation. It's not really a solution. For an issue of this magnitude, no one solution is going to be enough. There need to be multiple initiatives working in tandem. Reducing emissions from coal-based power plants offers the largest potential for air quality improvements. In addition, there need to be strong emission standards for industries. We need to reduce solid fuel use in households. We need to shift to different kinds of kilns for brick making. And introduce stronger vehicular emissions to make an impact in this area. Now, a big part of this issue can be addressed if we can find ways to stop and reduce the crop burning. But the ideal solution would be to find another use for the crop residue. So instead of burning it, farmers need to gasify it. Gasification is the incomplete burning of biomass or coal in a limited supply of air or oxygen. This is a two-stage process that yields a fuel gas that can be used for cooking, heating and power generation in the village in the first stage, and any type of transport fuel, diesel, aviation turbine fuel, methanol or CNG in the second. In India, the large-scale induction of this technology would not only end the annual invasion of smog, but would also supplement the income of the farmers. A win-win situation. Now, how else can this crop stubble be used effectively? Well, a group of scientists in a startup called Kriya Labs, incubated by IIT Delhi, have found a way to make cups and plates from this agricultural waste of the farmers.
Using our process, different grades of pulp can be made from rice straw and other agro residues also. And these different grades of pulp can be used to make multiple products. For example, paper, for example, biodegradable tablewares, for example, fabrics and bioethanol also.
How does this work? There are eco-friendly machines that break down the agriculture biomass into pulp. This is then converted into biodegradable products. This cellulose pulp can be a perfect raw material to make 100% biodegradable tableware, as they can decompose within 60 days. So the farmers can make money and contribute to a cleaner environment.
So therefore we are connecting rice straw to a premium market and thereby generating revenues for the smallest farmer also. And the revenue can be at least 5,000 rupees per acre, and incentivizing the farmers not to burn rather than earn from it.
Another step that could help with the amount of vehicular pollution in India is a change in fuel. Delhi was the first city in India to change emission standards to what is known as Bharat Stage 6 in 2018. The latest grade fuel will help reduce emissions of particulate matter by 10% to 20% in existing cars and two-wheelers, but it will help even more once vehicles have the same Bharat Stage 6 compliant engines.
We have the advantage to design our growth based on a much cleaner roadmap with a cleaner fuels, with cleaner technology, and a better and more sustainable mobility strategies. So if we can do that, India can certainly avoid the mistakes of the world.
Some solutions are in place, but is it just too little too late? After the break, we explore the destruction of the ozone layer. From the air in northern India, let's move to another huge environmental and health issue that affects our atmosphere: ozone depletion. Ozone is a highly reactive molecule that contains 3 oxygen atoms. The ozone layer is like a sunshade around the earth, protecting it from the heat of the sun. Its main use is that it stops harmful ultraviolet radiation emitted by the sun from reaching us. Through the years, this layer has been deteriorating due to the release of pollutants like chlorofluorocarbons or CFCs. These are usually emitted from cooling devices like freezers and air conditioners. Scientists have, however, discovered that they destroy the ozone layer. How did this happen? When CFCs reach the upper atmosphere, they are exposed to ultraviolet rays, which causes them to break down into substances that include chlorine. This chlorine then reacts with the oxygen atoms in ozone and rips apart the ozone molecule. One atom of chlorine can destroy more than 100,000 ozone molecules. Now this process has led to the steady destruction of the ozone layer. Fortunately, we have managed to come up with a way of handling this disaster. An international agreement commonly called the Montreal Protocol, signed in 1989, has helped stop the production of CFCs. In this agreement, nations came together and agreed to protect the ozone layer by phasing out the production and consumption of ozone-depleting substances. The Montreal Protocol has proven to be innovative and successful and is the first treaty to achieve universal ratification by all the countries in the world. This kind of agreement has sent clear signals to the global market and placed the ozone layer, which was in peril, on a path to repair. Let us now move from the atmosphere to our waters, to the coastline alongside Chennai, which was the site of a huge oil spill in January 2017. On the morning of January 28th, 2 ships, one entering and one leaving the port, collided. One of the ships, called the MT Dawn Kanchipuram, was carrying over 26,000 metric tons of spirit oil and about 6,000 metric tons of high-speed diesel. With the impact, the oil spilt over 72 kilometers from Ennore in the north, where the Kamarajar port is located, to Mamalapuram in the south. The rescue mechanisms kicked into place almost immediately. The Coast Guard came in to contain the damage. They started helicopter sorties and then cleaning operations that went on for days. Almost 208 tons of oil mixed with sludge and 99,000 liters of oil mixed with water were removed from these waters. Along the beaches and coastline of this area, a huge number of volunteers pitched in to help with the cleanup. But was this enough? An oil spill can have huge repercussions. If we look back in time to the oil spill along the Gulf of Mexico in 2010, the region is still feeling the impact today in terms of the environmental damage, in terms of destroying wildlife in those waters. So, what were the repercussions of this oil spill? There were consequences for the fisher communities whose livelihood depends on these waters. Whenever an oil spill occurs, marine life such as seabirds and fish will come in contact with it. Once fishes come into contact with the oil, their respiratory system will get affected and they could die. What about other marine life? In addition to fish, the olive ridley turtles who nest along the coast in Chennai and also from Ennore to Pulicat are now facing threats. Now, turtles need to come up to the surface to breathe while in the sea. Sometimes they ingest surface water while taking in air. The water contains toxic oil which they will ingest, ultimately leading to their death. The thick oil also washes ashore, creating reservoirs on the beach of toxic chemicals that can have a lasting impact on the environment. So what are the solutions? We travel to the Indian Institute of Science Education and Research in Thiruvananthapuram to explore a new material that has been developed that could help in oil spills. Let us see how this new material works. So what happens when oil spills on water? Most oils are less dense than water, so the spilled oil floats on the surface. It also emulsifies, which is a process by which the seawater gets suspended in the oil. This usually occurs by physical mixing due to turbulence in the oceans. Now the scientists in ICER have created a bead. When you add the bead to the oil in water emulsion, it is found to absorb the oil quite efficiently.
We started with a composite material. A composite material consisting of just cellulose pulp, which is very cheap. It's which is a precursor for paper industry actually. And we use this as a matrix. And we use our compound, we make a gelator. Gelator means something which can gel. Now this composite material, when we put in oil or oil water mixture, it selectively absorb oil and it gellify the oil part so that you can collect the oil along with this material and you can clean.
This kind of innovation could provide a much needed solution to something that would otherwise have a huge impact for generations on the coast and its inhabitants. From oil spills, we now head to explore a problem that is more common, that is in our face every day in every city: rubbish. Yes, the amount of waste that we accumulate, which is truly an enormous disaster. Keep watching to see how it impacts us and what we are doing to create change. We will now explore one more issue that affects every modern city. I'm talking about the solid waste we accumulate: plastic, metal, glass. This may not seem like a disaster since it is small amounts adding up every day. But when we aggregate the scale of the issue, we have a huge disaster on our hands.
India generates about 70-75 million tons every year, and about 70% of this comes from all the bigger cities, the class 1 cities, the metros, even some of the level 2 cities.
43 million tons of this is solid waste. And the issue is not just the waste, but how we dispose of it. Data shows that more than 30 million tons of garbage is left untreated and disposed of in an unhygienic manner. Mostly in landfills like this one, the Mammoth Ghazipur landfill. This is a huge dumping ground in the National Capital Region. Garbage has accumulated here for so long that it now stands 7 stories high, and it is growing with about 3,000 tons of garbage getting dumped here every day.
Disposal is a crisis. In the end, the landfill only has a limited life. So all the waste is really going into the groundwater, and you're drinking like a kind of waste soup. And that is really terrible because you have poisons all over the world landfills pollute water.
But is this how landfills are supposed to work? Not really. A landfill, in its simplest form, is an engineered pit in which layers of waste are filled, compacted, and covered. It is supposed to be lined at the bottom to prevent groundwater pollution and isolate the garbage from the environment. Every day, after the garbage is dumped, it is meant to be covered with a layer to prevent odors and pests. It also has a capacity. This capacity is supposed to be chosen based on an environmental risk assessment study. And when we stop using the landfill, we are supposed to cap it and monitor it. But in reality, this is how it works. In most landfills, the garbage leaches into the groundwater, polluting it. It also releases toxins into the air. In Ghazipur, of course, the level of the disaster is more than just water and air pollution. For example, the landfill is almost always on fire. This is because the decomposing waste produces methane and carbon dioxide. Methane is both flammable and explosive. This landfill is so high that it also collapses, often with injury to both property and people. What solutions are possible? We traveled to the outskirts of Mumbai to the Adharwadi dumping ground of Kalyan. Like most landfills, this one had fires, bad odors, and was polluting the water table. The Kalyan Dombivali Municipal Corporation, or KDMC, decided to try bioremediation technology to see if it could improve the situation. In this technology, bacteria is added which digests the entire organic waste. This helps in the recovery of 30% to 40% of the land. The remaining inorganic waste is recycled or reused. Whatever residue remains is covered with grass and plants. The technology also minimizes the contamination of groundwater. All of these, the steps in the right direction. But the idea needs to be replicated to have an impact. But the real long-term solution is generating less waste and managing the waste we generate better. For example, we could all segregate our waste. It's quite simple. All we need to do is separate our biodegradable and non-biodegradable wastes. Now, what does that mean? It means that less waste goes to landfill, which makes it better for the environment. We traveled to a small town called Madukarai near Coimbatore in Tamil Nadu to see how they manage their waste. The community ran the scheme as part of a CSR initiative of ACC Cements. So what happened is that a team of women was put together that would go from house to house collecting the waste.
The women have been picked from Madukarai, and 3 self-help groups have been formed which contain 55 women. The women are supposed to collect waste which is kept outside the houses and segregate it. Almost 90% of the waste is recycled, which has helped in making Madukarai a very clean place.
The wet waste is then converted to compost. The compost is then sold to farmers. A lot of the solid waste like plastic, rubber and glass is recycled. Some of the hazardous waste is put in a calciner. When the temperature reaches about 950 degrees, all hazardous material is burned down completely without generating any side effects in terms of pollutant gases. The town is small, with only around 40,000 citizens. But the idea of the community taking responsibility and managing their waste is a model that can be scaled up. Today, we need more stories, more solutions to manage our environment. There are an overwhelmingly large number of environmental issues that threaten our increasingly fragile world. It is estimated that by 2030, the world population of 7 billion will demand twice as many resources as our planet can supply. Meeting these needs economically or ecologically will require creative problem solving. And the only long-term solution has to be to take responsibility and develop a culture of sustainability.